Hello, and welcome to Logic, an introduction to digital electronics. This is going to be a very brief introduction, because possibly a lot of the stuff I'm going to say here you're not going to use in your final project. But I want you to know that it exists and what it does, so that if you need to use it, you can look it up in more detail online, or ask me for help or something and get better information and really use it. So the first thing I want to show you is this guy. It's an inverter, or a NOT gate, depending on how you like to say it. If I hit this switch here and turn this side of the circuit off, this one goes on. And if I turn it back on, it goes off. So all this is doing is it's taking the current here and it's turning it off over here. Now I should stress that this image here is a little bit deceiving, because all you're seeing is one wire and then a light at the end, which you may be thinking to yourself, Ben, that's not a full circuit, and it's not. Because for some reason Yanka assumes that you've already got an input voltage to here, and that you don't actually need to have, like, it doesn't require you to have the whole circuit, which I find kind of annoying. I would prefer that I have to do the whole thing, but you don't, so that's okay. We can deal with that. So just know that for all of these components, there's gonna be some wire that's providing it a voltage that you're just not seeing. So anyways, that's the inverter. Moving on to the AND gate and the NAND gate. The AND gate works by as soon as both of the two inputs are in the on state, the output will change to on as well, as you can see by these logic indicators. The NAND gate, which is short for NOT AND gate, is just an AND gate with an inverter at the end, and you know it's different because of that little circle right there at the end of the tick, just like the inverter. And if so, I guess if you change both of the inputs to on, the output will turn off and not before. The OR gate, you probably already guessed that if either one of these inputs are on, or both of them, the output will be on, and that if either one of the inputs on the NOR gate are on, or both of them, the output will be off. The flip-flop is maybe a little bit less obvious at first, but if I were to press this button here, the S lead, the output turns on, even if I hit it again over and over again. But as soon as I hit the reset button, it turns back off again. And I can just keep doing this, turning it on and off by toggling the two different buttons. And this is really useful for memory latches, or if you need to keep your circuit on, which is called a bistable circuit. This here is a decade counter. And it's not really a logic gate necessarily, but it's got a lot of logic gates in it. What it does is it's an integrated circuit, or a microchip, which would look a little bit like this, but with less pins. And basically, it's a big circuit which has been condensed into this little component you can put in your circuit, which is just awesome. So here's how it works. You've got a clock input here, which I've just used. This input is just going on and off automatically. And if I hit the enable button, switch, I mean, all of these outputs kind of go down this row of output loops. Every time this clock goes on, it advances to the next one. If I hit the reset button, it shoots back up to the top, and if I enable, it pauses. So we can pause it and then put it back at the top as we had it originally, or just let it go. So yeah, these are basically the main components I want to show you, except for one more. I have one that's, I'm going to show you in a bit, that will help you create a clock input like this if you want. First I'm going to show you a little application of these here logic gates. This is called a multiplexer. And it's used in a lot of digital electronics. In fact, almost every digital electronic you have has tons of these inside of it. And how it works is it takes 3 different inputs that can be any state, and it expands that into one of 8 different outputs. Well, I don't know if that's making a whole lot of sense, but if you have, well, I'll just show you. For every different combination of ons or offs with these lights, I get, with these inputs here, a different pin or a different light down here will turn on. And this is useful for a whole lot of things. If you were to go really advanced, you could say data transmission from your computer. But for our purposes, I don't know, this is just a good example of what you can use the AND gates for. By the way, these are all AND gates. They're 3 input AND gates, so all 3 must be on for this to be on. And these are inverters. And you can, I won't explain the whole thing. You can take a look at this, pause the video if you want, and really try to figure this out, or look it up if you want to. But yeah, okay, next thing. This clock, I'm going to show you a little bit of an example if you wanted to build one of these, or what you'd use. Okay, so this is an integrated circuit called the 555 timer. And I actually have a picture of it here. This is what it looks like on the inside. And even here, not all of the components of the circuit are properly depicted with schematic diagrams, because there's just so many different things. It would be hard to display it all in a little picture like this. So yeah, okay. What it does, it turns things on and off. It's really how it works. And you can define the timing interval between ons and offs by changing the values of these resistors or this capacitor. So if I make this capacitor smaller. Okay, yeah, that's actually, I'm glad I did that. This is why I want you guys to simulate all of your electronics in Yanka first before building them by hand. So what I did here is I made this capacitor too small, and I actually overloaded this integrated circuit, and I broke it. And if you do that in real life, well, then it's gone, we have to get a new one. But if you do it here, then you just hit the repair button and you fix your little capacitor or whatever, and everything works out just as well as it ever had. So yeah, okay. 555 timer. You can find lots of information on this online. It's really simple, guys. If you change the values of your capacitors or whatever, you're going to change the time that this light bulb is on for. And you can see here the voltage on the capacitor is rising and then falling, and then anyways. And if you were to change, oh, it did it again. And if you were to change the values of the resistors, the same thing happens, because the resistor restricts the speed at which the capacitor can drain, and that's what the timer uses to do all its timing. So yeah, you can change the time of the overall cycles and the time and the ratio between on time to off time as well. And you may, probably almost all of you are going to need to use some sort of timer in your final project. So yeah, I guess I've just given you a bit of a bonus, bit of a hint as to how that's going to work out. So yeah, I hope this made a lot of sense, or at least some sense, to people. If not, the internet is your friend. I am also available to answer questions. I assume there's probably going to be a bunch of them. But yeah, until next time.